Hello and welcome to Qubit Tech Talk, October 2021. I'm Josh Mandeville, the CTO of Qubit Networks. We're going to talk today about virtualization. It's a little series I'm going to do maybe a couple months in a row on virtualization and the hardware behind it. But today we're going to talk about virtualization, give a brief history of virtualization, talk about VMs. Those have become very popular, and this is a very high-level overview for people that don't quite understand what a VM is. We're going to touch on containerization. It's just another way to virtualize, and I'm just going to go over a few things. So the history of virtualization is we saw some stuff happen in the 1960s when compute started with time sharing, and we saw, hey, it would be great if two users could log into this computer at the same time in the 70s, which brought about Unix, and which gave way to Linux. Not that Unix is gone, but most things are on Linux these days. And we saw time sharing, compute sharing, and network sharing in the 70s and 80s. And there was all across all kinds of different hardware. This gave way in the 1990s to using commodity hardware. In other words, using similar standardized server hardware based on x86 processors. I mean, there were some others out there, but this in the 90s we started to see this largely get adopted to get rid of the application-specific hardware. I'm talking to you, AS400. At least it started the trend back then. Fast forward to the early 2000s, a decade later, this is when we see virtualization really take off. And part of that is we see hardware really take off. The performance of hardware, the performance of CPUs, RAM, storage, all of that takes off, and it keeps getting smaller. So in a server chassis, you get a lot more power. They started being more efficient, reducing costs associated with it. It really solved two problems. One, we could partition up this hardware in the same piece, the same server hardware, into multiple applications and operating systems, which allowed people to use legacy apps and even virtualize simple tasks that weren't using the full extent of hardware, and bring it into less cost, less power, less setup time. It gave way to the advent of hypervisors, which we're going to talk. That's the core layer that allows this to happen on hardware. Virtualization's widespread acceptability really helped reduce vendor lock-in, because now all your services are running in a VM. I'm going to get into this, rather than a specific type of hardware. And virtualization is what really gave way. The uptick of virtualization and the advancement of virtualization is what gave way and is at the core of cloud computing. It's so prevalent across the enterprise today that there's specialized software to manage and keep track of all your virtualization. vCenter, Hyper-V, QEMU, Overt, Proxmox, and there's even more when you get into containerization, which I'll touch on later. So I have a little presentation. I'm going to jump into it here. And here we are. So what is a virtual machine? Well, it's based on hardware. First, you have your hardware. You have your server. You have CPU, RAM, storage, and network, all going into this one box, right? Then on top of that, you have what's called the hypervisor. In VMware, it's ESXi. In Microsoft, it's Hyper-V. It just allows you to carve up this. I'm going to turn on my laser pointer. It allows you to carve up pieces of this hardware into other things. So what's next? Well, we have a guest OS. In other words, we get to install an operating system and a file server, let's say, and it doesn't know that it's a VM. I mean, there's a lot more operating systems that are well aware that it's a VM right now, but it separates it off from the other print server, from the mail server, in case you need those, in case they're different OSs or different versions of OSs. You can now run different versions of operating systems, all in the same chassis of hardware. So how did this come about? It used to be, before virtualization, here's some typical sample infrastructure, let's say. You would have a mail server. on a box. You would have a web server on a box. You would have a file server on a box, a print server, a wireless controller, a camera server, directory services, SQL server, all kinds of different things. You'd have them all in a different box. I just threw a couple up for example. Well, as the hardware increased, as the efficiency of the hardware got better, the hardware got more powerful. There was more CPUs got more powerful and smaller, and RAM got the ability to use more RAM became more prevalent, and hard drives and storage got faster and bigger networking. Those boxes of that hardware were vastly underutilized. So we went from 6 boxes using a decent amount of resources to 6 boxes basically using 25% or less, maybe a little more, of resources. But a lot of these tasks were no longer using the full power of the box that they were in. So fast forward, we go from 6 servers using about 25% of the resources of new servers to virtualization, where we've now split this up across 2 servers rather than 6, and we're still only using 75% of the services. This is a brief, high-level overview of what virtualization is. I'm just warning you for all the tech geeks out there that say, hey, what about this? What about this? This is just a high-level overview of what virtualization is. So, a more efficient use of hardware is great. But what if one of these servers dies? So this is where high use of the availability and the software to manage these, like vCenter, came into being. So we go to 3 servers rather than 6. That way, if any one of these servers dies, the other server is not overloaded, and we have redundancy. And now we're 3 servers to 6 with high availability. Your mail server doesn't go down. If one server goes down, it gets moved over to a different server. And so this is the redundancy. One server dies, file moves over here, print moves over here, and we're not down. You may have a blip of outage. Like I said, this is just high level. This is the power of virtualization. One of the great benefits is super efficient use of the hardware that we have today, and then the ability to do high availability and business continuity. Keep your services running even if we have a piece of hardware die. So, like I said, I was going to touch briefly, very briefly, on containers. Containers are a type of virtualization. But instead of the normal hardware and then a hypervisor, you have a hardware, then an operating system, a core operating system. It's going to be a NIX, Unix, or Linux. There's FreeBSD. There's Ubuntu. There's all kinds of different versions and distributions out there that have the ability to do containers. And then you have a container engine, Dockerd, Containerd. There's the jails for FreeBSD. These are all different types of container engines. But instead of isolating the full operating system, what we're doing is isolating the apps, like the web app. I have a Minecraft server running in a jail on a TrueNAS server. It's a containerized version of a Minecraft server, and then I have a media server. The benefits of this is you're not duplicating the full operating system every time, but it's a very specific use cases, because I will give an example. I upgraded Java on the base operating system here, and I created a Minecraft server. I upgraded the Java so it would allow a new Minecraft server. It broke all the old Minecraft servers. Even though I spun up a different jail, it was still using the library of Java on the base operating system. So if everything here works well and the libraries that you need here will all work together, it'll containerize these different applications. Just a very brief explanation of containers. There's a ton of use and a ton of web apps that are using containers all across the internet, and its ability to scale up quickly is amazing with containers. It has made even more efficiencies come out. It's just that it's a little different than a VM. So here's them side to side. In a virtual machine, you have hardware, then a hypervisor, and then a full operating system with your application. Whereas in a container, you have an operating system, a container engine, and then just the application itself is isolated versus the whole operating system. This operating system doesn't know about this operating system unless you tell them about each other in a virtual machine environment. So what does this do for clouds? Azure, AWS, Google Cloud all have versions of both of these. We have seen there's a huge question right now. Should I move to Azure? Should I move to AWS? It's actually a little more complicated than it used to be. While the management of all of the clouds are a little easier, like the interfaces have gotten better, should I move to the cloud has gotten a little more complex. And it basically comes down to, am I moving a VM? Am I moving my application to a service? And virtualization has given us the ability to have all this availability in the cloud, whether we do a full virtual machine or a software as a service or an application as a service. And you can think of those as containers or containerized applications. But it's a really cool time to see how this works, and having hybrid solutions of virtual machines and containers and on-prem and cloud. It's all really cool, and it's just made for more efficient use of the hardware and more efficient use of our budgets. So that pretty much ends today's Qubit Tech Talk. Just like to say thank you, and thank you for tuning in. And if you have any comments, please leave them down below, and we look forward to seeing you next month. Thank you. Bye.